Hello friends, welcome. In this video, we are going to discuss the different types of flip-flops and their uses.
Flip-flops are electronic circuits used to store binary data in digital systems. A single flip-flop can store one binary digit. The easiest way to construct a flip-flop is to connect two inverter gates or NOT gates in series. This arrangement is also known as a feedback line. When a high state is given as input to the inverter A, the output got from the inverter B will be high. Likewise, when the input of inverter A is made low, the output of the inverter B will also be low. The inverter flip-flop model is used in the construction of static random access memory. NOR flip-flops utilize the principle of positive logic for its functioning. NOR flip-flop is constructed by connecting two dual input NOR gates with the output line of the first NOR gate connected to one of the input line of the second NOR gate and the output line of the second NOR gate connected to one of the input line of the first NOR gate. The control input lines R and S are applied at each of the remaining input line of the NOR gates. The flip-flop produces two complementary outputs, namely Q and Q bar. In the first input condition, when both the control inputs R and S are made low, the output of the present state is continued without any change. In the second input condition, when the control input R is made high and the control input S is made low, the Q output is reset to low state. In the third input condition, when the control input R is made low and the control input S is made high, the Q output is set to high state. During the fourth input condition, when both R and S control inputs are made high, it results in the forbidden state called race condition. NAND flip-flops utilize the principle of negative logic for its functioning. NAND flip-flop is also constructed by connecting two dual input NAND gates as it is done for NOR flip-flop. The control input lines R bar and S bar are applied to the input line of each NAND gate respectively. NAND flip-flop produces two complementary outputs, namely Q and Q bar. In the first input condition, when both the control inputs R bar and S bar are made high, the output of the present state is continued without any change. In the second input condition, when the control input R bar is made high and the control input S bar is made low, the Q output is set to high state. In the third input condition, when the control input R bar is made low and the control input S bar is made high, the Q output is set to low state. During the fourth input condition, when both R and S control inputs are made low, it results in the forbidden state called race condition. Race condition is an indeterminate state in which we cannot predict whether the output of the flip-flop will be made high or low.
Race condition is a problem faced with NAND and NOR RS flip-flops. This drawback is avoided in D flip-flops and JK flip-flops.
D flip-flop is constructed with only one input and hence race condition is avoided in D flip-flops. The D flip-flop is disabled when the input is low and it is enabled when the input is high. Operation of flip-flops in computers and other digital devices must be synchronized with the help of clock pulses. Therefore, flip-flops are constructed with clock enabling circuits using AND gates. In positive level clocked flip-flops, the outputs are enabled during the high state of the clock pulse, and in negative level clocked circuits, the flip-flops are enabled during the low state of the clock pulse. In simple level clocked flip-flops, the output is transparent to the input and therefore the output follows any change of state at the input. Spurious signals caused by problems such as switch rebouncing may yield undesirable results at the output of the flip-flops, and this is known as false triggering.
False triggering is an issue caused by disturbances in the input control signals of level clocked flip-flops. This setback in flip-flops can be solved by replacing level clock with edge-triggered clock.
To avoid false triggering, edge-triggered clock signals are generated using a capacitor-resistor circuit placed in the path of the clock pulse. In an edge-triggered clock, the signals are active only at the rising or falling edges of the clock. Positive edge-triggered circuits are enabled during the rising edges and negative edge-triggered circuits are enabled during the falling edges of the clock. Edge-triggered JK flip-flop is constructed from an edge-triggered RS flip-flop by connecting its Q output with the input of the lower AND gate and connecting its Q bar output with the input of the upper AND gate. In the first input condition, when both J and K inputs are low, the flip-flop maintains its current state in the output. In the second input condition, when J is low and K is high, the output is made low. In the third input condition, when J is high and K is low, the output becomes high. In the fourth input condition, when both J and K are high, the flip-flop changes the state of its output from low to high or high to low for every consecutive rising or falling edges of the clock. This state of JK flip-flop is known as the toggle state or T state. The JK flip-flop with both its J and K inputs permanently connected to high state is called as the toggle flip-flop or T flip-flop.
Flip-flops are widely used to construct registers, buffers, counters, event detectors, frequency dividers in digital devices. Hope this video has enabled you to understand the different types of flip-flops and their uses. Thanks for watching.